Hey guys, in this video we're going to learn how to factor a quadratic and then also solve it in order to find our roots, our solutions, x-intercept, zeros, and being able to find that from a polynomial equation. So when we're given a polynomial equation, we're going to see if we can factor out the GCF first and then go through the process of factoring and then solving to get our solutions. Alright, so whenever we're factoring or whenever we're solving our quadratics, we always have to first make sure that our quadratic is set equal to 0. So if you look at this case, we have 4x squared minus 4x equals 8. We don't like the fact that it equals 8. So we're going to subtract the 8 from both sides first. So then we have 4x squared minus 4x minus 8 equals 0. So don't be confused because I can't actually subtract 8 from 4x. So they're not like terms, so I rewrote the entire equation as 4x squared minus 4x minus 8 equals 0. This is key. When you're solving a quadratic, you must make sure that it is equal to 0 first. So now, looking at the left side of the equation, we're going to see if we can factor out a GCF. So we're going to write our ladder and write all of our terms, 4x squared, negative 4x, and negative 8, into our ladder. And notice that we can factor out a 4, so what's left over is going to be an x squared, negative x, and negative 2. And whatever is remaining looks like we just have a 1, so we're going to multiply the 4 and the 1 out to get our GCF as 4. So going back to the left, we're going to write the quadratic with the 4 factored out. So we have 4 times x squared minus x minus 2. So what's left over, we're going to make our x, or in our diamond, we have a negative 2 on our bottom, which is our c term, our a times c, and our b term is negative 1. So we have to think of two numbers that multiply together to get a negative 2 and add to get a negative 1. So I can think of actually, negative 2 and 1 would multiply together to get negative 2. If I add these two numbers together, it's going to give me negative 1. So I'm going to go back and I'm going to write the 4, and then we're going to replace the negative x with a negative 2x and a positive 1x. We get negative minus 2x plus 1x minus 2 equals 0. So now we have our two groups, and we're going to factor that right away. We're going to look at the first group, and we can take out an x in the first group, so I'm going to factor out the x, and notice how I turn this parentheses into a bracket. So we have x times what's left over is x minus 2. So instead of creating a ladder, I've overstepped that step, and factored out the x, left with an x minus 2. So the second group, there is no GCF other than 1, but I'm going to show that I'm factoring out the 1 like that, and I'm left over with an x minus 2. Close off the bracket equals 0. So I'm looking at my two groups again, and if you look closely, they both have an x minus 2 in each group. So I'm going to drop down the 4 and factor out the GCF, which is x minus 2, and I'm left in the first group with an x and a plus 1. So now here we can apply the zero product property where our x equals, we have a 4 times x minus 2 times x plus 1, and that equals 0. So if we're multiplying three terms, or two binomials and a monomial, we can use the zero product property. And here's our first solution, second solution, and our third solution that we're going to pull from. So we're going to write three equations. We have 4 equals 0, we have x minus 2 equals 0, and x plus 1 equals 0. Looking at the first equation, does 4 ever equal 0? Good, no, so that's not even a solution. But we look at the second equation, we have x minus 2 equals 0, so we're going to add 2 both sides. That zeroes out, so we have x equals 2 as our first solution. So then x plus 1 equals 0, so we're going to subtract 1 from both sides, and now we have x equals negative 1. So these are our two solutions from the quadratic of 4x squared minus 4x equals 8. So going through this process, we have to set our equations equal to 0 at all times when you solve a quadratic, then go through the process of factoring, and then use the zero product property to figure out what your actual solutions are. Our second part, we have 2x squared plus 5x plus 2, and lucky for us, it's already set equal to 0. So then I go right into my factoring method, so I have to look at to see if I can pull out a GCF, which I cannot. I don't see anything in common with 2x squared plus 5x and plus 2. So I'm going to go into my diamond and see what two numbers I can multiply together to get 4 and add to get 5. Easy, 4 and 1. So I'm going to replace the 5x with the 4x plus 1x, and I have my two groups to make two ladders. But I'm going to overstep that step and look at my 2x squared plus 4x, and I have a 2x that I can factor out first. Left over is x plus 2 from this first group alone. And then my second group, it looks like I can only factor out a GCF of 1, so I'm going to show that, and I'm left with an x plus 2 equals 0. So then I have two groups again, and they both have an x plus 2, so in the first group I factor out the x plus 2, I'm left with a 2x, and the second group I'm left with a plus 1, and that equals 0. So here we have the zero product property that we can apply, so we have our x plus 2 equals 0 as our first possible solution, and then 2x plus 1 equals 0 as our second possible solution. So we solve both equations for our x, subtract negative 2 from both sides, x equals negative 2, subtract 1 from both sides, 2x equals negative 1, divide by 2, x equals negative 1/2. In this third example, we're going to factor and solve the quadratic, and I've noticed that I don't have a b term, but I have two terms being multiplied together. I notice that 16t squared is a perfect square and 25 is a perfect square, so this must be the difference of two squares. So when I factor the difference of two squares, I know that the first term is a perfect square because that can be broken up into 4t times 4t, and 25 can be broken up into 5 and 5. So notice how the second term has the same exact number as its factors, and then the first term has the same exact factors as well. 4t, 4t, 5, and 5. So then the difference of two squares, this quadratic can be factored into two binomials, 1 plus 1 minus. So we write the first term 4t in both first spots, and then our second spot will be our 5 and 5. So then using the zero product property now, we have 4t plus 5 equals 0, and then 4t minus 5 equals 0. So in case you're wondering why I'm writing down 1 and 2, I'm just trying to point out that we have our first solution in this expression set equal to 0, and then our second expression set equal to 0. Just to show you that we have two different solutions in this case. So we solve for our value of t. So subtract 5 from both sides, that zeroes out, 4t equals negative 5. Divide both sides by 4. So our first solution is going to be t equals negative 4/5. Second equation, we're going to add both sides by 5. That zeroes out, 4t equals 5. And then divide both sides by 4. We're left with t equals 5/4. So one's going to be negative, one's positive. These are our two solutions in our quadratic. Alright, in our last example, we're dealing with a negative 3z squared plus 24z equals 48. So like I've told you before, we must make sure that our quadratic is set equal to 0 before we actually solve our polynomial equation. So what we're going to do is we're going to subtract 48 from both sides first. Again, these are not like terms, so we can't subtract the 24z and a negative 48, or and a 48, so then we're going to rewrite the left side as negative 3z squared plus 24z minus 48 equals 0. So after we set our equation equal to 0 by subtracting the 48 from both sides, we're going to make our ladder and see if we can factor out a GCF. So we're going to write all of our terms in the ladder, and notice that we can pull out a negative 3. So what's left over is going to be a z squared minus 8z and 16, positive. So over to the left, I'm going to rewrite the equation after I identify that the GCF is negative 3, of course. And I have a negative 3 times the quantity z squared minus 8z plus 16 equals 0. So what's left in my quadratic, I'm going to create my x, or my diamond, and in the bottom is going to be my a times c, which is 16, and our b term is negative 8, so two numbers that we can multiply together to get a 16 and add to get a negative 8. 8 and 2 doesn't work. Got it. -4, -4. So I'm going to replace the negative 8z with the -4z. So I have -3 times the quantity of z squared minus 4z minus 4z plus 16 equals 0. So I have my two groups. So then in my first group I can factor out a common factor of z. So I'm going to show that. As my GCF is z, I'm left over with a z minus 4. And in the second group I can factor out a -4 from both terms. And I'm left with a z minus 4 equals 0. So then I have two more groups again, and they both have a z minus 4 in common, so I'm going to rewrite the -3 on the outside, write the GCF of z minus 4, and I'm left with a z minus 4 from both groups. And now we can apply the zero product property here. So we have 1, 2, 3 different terms that three different solutions we're going to have. So we have -3 equals 0, z minus 4 equals 0, and z minus 4 equals 0. So the first one we have -3 equals 0, and that is never a true case, so we're going to cross that off right away. And then we have z minus 4 equals 0, so we're going to add 4 to both sides. So we get z equals 4, and that's our first solution. So if we look at the second equation, notice how it's the third equation, it looks exactly like the second equation. So because they're the exact same, we don't have to solve that one. It's going to be z equals 4 again. So then our answer is z equals 4. Alright guys, thanks for watching. We've learned how to factor and solve, I guess, more complicated polynomial equations where we're dealing with quadratics, where our a is equal to 1 and our a could be greater than, or I guess not equal to 1. Make sure that we always set our quadratics equal to 0 before we actually solve it. Alright, thanks.